Good morning, everyone. Today we are going to learn about trigonometry. Here we see a couple of special triangles. The 30, 60, and 90-degree triangle has sides of A equal square root of 3, B equals 1, and C equals 2. C is always known as the hypotenuse, and A and B are the legs. For the 45, 45, 90-degree triangle, the legs of A and B are equal to 1, as C as the hypotenuse is equal to square root of 2. Sine theta is equal to opposite over the hypotenuse. Tangent is equal to the opposite over adjacent, and also equal to sine theta divided by cosine theta. Cosecant theta is equal to 1 divided by sine theta, which is equal to the hypotenuse divided by the opposite. Cotangent theta is equal to adjacent over opposite, and it's also equal to cosine theta divided by sine theta. Cosine theta is equal to the adjacent over the hypotenuse. Secant theta is equal to the hypotenuse over adjacent. Or it could be 1 over cosine theta as well. Now we have something known as the Pythagorean theorem, which is a squared plus b squared is equal to c squared. Now here is how we solve for a. We would have to subtract b squared from both sides, and you get the equation of a squared is equal to c squared minus b squared, and take the square root to both sides, and we get a is equal to the square root of c squared minus b squared. Normally you have a plus or minus case where you take the square root to both sides, but in trigonometry you only want the positive case. Now let's scroll over to a squared plus b squared equals c squared, and this time we are going to solve for b. So we need to subtract a squared from both sides, and you get b squared is equal to c squared minus a squared. Then take the square root and you get b is equal to the square root of c squared minus a squared. And then on the other side you have another equation of a squared plus b squared is equal to c squared, and then you solve all the way down.